Okay, this is the solution to practice exam over chapters 1 and 2. The first question deals with the volume of a sample of magnesium as a ratio of the mass per unit volume. So the densities of 3 liquids are given, and we're being asked to determine on which liquid this magnesium will float. So if we think about the density of the liquid, if the density of the liquid is really high and the density of the magnesium is particularly low, then the magnesium is going to float. But then if the magnesium ends up having a greater density than the liquid, then it's going to sink. So what we want to do here is calculate the density of magnesium. We take its mass, divide by its volume, works out to 1.69 grams per ml. And so this magnesium should sink in the first 2 liquids and then float on the third. And so it's going to sink in the first 2 and then only float on dibromomethane. Okay, number 2, Dalton's law of definite proportions. This is the one that has to do with things like carbon and oxygen forming a compound like CO2. We have 1 C to every 2 O's. You can imagine a different compound, maybe like CO, that forms as well. You might even be able to consider, maybe a molecule like N2O3. So you get these compounds forming as some sort of ratio of the elements. Okay, so let's take a look here at the choices. So the ratio of the masses of an element in a compound is always the same. And that is basically the definition of this term. So that the carbon dioxide always contains 12 grams of carbon for every 32 grams of oxygen in the sample. So CO2 is always 1 carbon for every 2 oxygens. So that's going to be the right answer. So the total mass changes during a chemical reaction. Well, the mass should stay the same during a chemical reaction. But also that has nothing to do with the law of definite proportions. That would be the law of conservation of matter. And so C, the mass of one element which combines with the mass of a second element are in a ratio of whole numbers. Well, in a weird case with N2O3, with that compound or compound like N2O5, you kind of see that the ratio of N to O is actually not in a whole number ratio. So the whole number here would be like for every 1 N, there's 1.5 O. So you can see that the ratios doesn't necessarily have to be whole numbers. You could have fractional ratios for the elements in a compound. So statement C would be incorrect. And then D is it is not possible for the same 2 elements to form more than 1 compound. So that's also not true because you see like things like carbon monoxide versus dioxide commonly exist. So D is not true. So only statement A is true. So 3, an element's most stable ion forms an ionic compound with chlorine having the general formula XCl2. If the mass number of the ion is 88 and it has 36 electrons, what is the element and how many neutrons does it contain? Okay, so we're just basically working out here from some of the details given what we might know about this ion. And so we know that the X is going to have a 2+ charge because the chlorides have a -1. And so then we know that whatever this element is, that it should have 38 protons. And then, as it has in the 2+ form, 36 electrons. Because in the neutral form, it would have 38 electrons if it were neutral. And so what is the element? How many neutrons does it contain? So we would go to the periodic table and inspect and find that strontium has 38 protons, so this would be strontium. And then the mass number of 88, subtract the number of protons, would leave behind 50 neutrons. Number 4, what is the correct formula for aluminum oxide? Aluminum 3+, O2-, so Al2O3. That balances out the 6+ and a 6-. So you can kind of take your coefficients this way. If you need to balance them out, you can do that. Then we end up with Al2O3 for this one. So moving on to number 5, HBr2 is which of the following acids? So this ion, BrO2- would be bromite. Because we know bromate's the BrO3-. And so the ites in their acid form would be us acid. So this should be bromous acid, D. Quick name of N2O5 would be dinitrogen pentoxide. We had mentioned in class that you might call this pentaoxide and you sort of abbreviate this as just pentoxide in the actual name. We're not going to be testing you on the small little nuances of when you combine vowels together, just in case you're wondering why this is pentoxide instead of pentaoxide. Not the biggest deal, it just tends to sound better that way, if you will. So number 7, the total amount of fresh water on Earth is estimated to be this quantity. What is this quantity in cubic meters? So this is just a conversion problem. So we go 3.7 times 10 to the 8 cubic kilometers. Big conversion here is that 1 kilometer is 1,000 meters. We cube that, so we have the cubic meter, cubic kilometer, then we have to cube the 1,000. And so this will end up being times 10 to the 17. And so, and I'm going to double check that arithmetic, but the whole idea here, 3.7 times 10 to the 8 times 1,000 raised to the power of 3, 1,000 caret 3. Yep, so 3.7 times 10 to the 17. Number 8, which atom has the least number of neutrons? So there's no way of just looking, you just have to work it out. So carbon has 6 protons, so we do 14 minus 6, that would be 8. Nitrogen's 7 in terms of its atomic number, so that would be 7 neutrons. Oxygen's atomic number is 8, 16 minus 8 is 8. Fluorine's atomic number is 9, so 19 minus 9 would be 10 neutrons. And the neon's atomic number is 10, so 20 minus 10 means that neon 20 would have 20 neutrons. So these are all the neutron counts that we've worked out here. So the least one would be nitrogen 14. So I convert picoseconds to seconds. The ones I mentioned that we should know in terms of the prefix conversions are like giga, mega, kilo, centi, milli, micro, nano, and pico. I'm not sure what the other classes told their students, but this is what I think are worth knowing because these are the common ones that we'll use in a class like this. So we're going number of seconds here would be equal to 525 picoseconds times 10 to the 12 picoseconds are in 1 second. So second has a whole lot of the small thing in it. And so you might just remember minus 3, minus 6, minus 9, minus 12 in terms of the conversion. Now the minus might work out if you say, how many seconds are in a picosecond. 1 picosecond is 10 to the minus 12 seconds. Okay, and so that should work out to probably be, but let's do this real quick, 525 divided by 1e to the 12, or divided by 10 caret 12 is, it's answer B. So which of the following is the cerium to cyanide? So cerium is Ce, mild trick here, chromium is Cr. So cerium is Ce, so by process of elimination we can roll out D and A. This is one that I guess isn't in our nomenclature. That's technically the azide ion, but you might not recognize that one, but it doesn't matter too much. We should identify cyanide as Cn minus. Cerium 2 plus should be CeCN2. So ammonium bromate is this one here, ammonium plus bromate. So ammonium bromate. 12 was the name of formula of magnesium dihydrogen phosphate. So just break this into parts. H2PO4, that would have to have a minus charge because I have 2 H pluses added on to the originally PO4 3 minus. So then I'm going to have magnesium 2 plus, so I'm going to need 2 of the minuses. So this should be Mg parentheses H2PO4 2. What does the atomic number specify for an element? The number of neutrons in the nucleus? Nope. The total number of neutrons and protons in the nucleus, that's the mass number. The number of protons in the nucleus, that's true. The number of atoms in 1 gram of an element, that's just nonsense. The number of different isotopes of an element is also just nonsense for, we don't track that number per se. So this would just be the number of protons in the nucleus, which compound is formed between strontium and nitrogen ions. So strontium only forms a 2 plus. It's in the magnesium group. It's an alkaline metal. Nitrogen's common ion is a 3 minus, so we're going to go strontium 3 and 2. So balancing out a 6 plus and a 6 minus. What is the correct name for this? Calcium bromide. So just calcium bromide. We're trying to test you that the dyes are used on binary molecular compounds. This is an ionic compound. It's an ionic compound because I know how to name these things as ions. What is the formula, or excuse me, what is the name of CBr4? So it'd be carbon tetrabromide. Okay, so the IDE ending for the second element, not the element ending. And we don't need the mono in front. And carbon 4 bromide would be the name if it were an ionic compound, but it's not. This is a molecular compound. What I'm looking at is that this molecule is comprised of non-metal atoms. To be an ionic compound, you need some sort of metal mixed with a non-metal. 16, nitrous acid. So this would be the acid of nitrite ion. So that would be HNO2. So nitric acid. I'm not sure this even exists, but if it did, it would be called pernitric acid. I don't think that makes any sense here to name that. But HNO, this might be hyponitrous acid. Again, probably doesn't exist, but if it did, we would call it hyponitrous acid. Sig figs, so 15.55 minus 4.2. This is going to end in the tens place when we do the subtraction, so we do 15.55 minus 4.2. The result's going to be good to here. So it'll be 3.5, and it'll still be 11.35. So that has 3 sig figs. We're going to divide that into this sum here. So we're going to end in the hundredths place. And so then we're going to pick up an extra sig fig because this is going to go 100 or whatever point XX. This will have 5 sig figs. Divide that into 3. The result should have 3 sig figs. So copper has 2 natural occurring isotopes, the predominant one being 63 copper. With the given isotopic mass and abundance, what is the mass of the other isotope? So I think we worked, in fact this might just be a poor example of a problem we've mostly already worked out, but we just take the fraction that's copper times that atomic weight plus the fraction that's the other, so that would be 1 minus 0.69150 times the atomic weight of that second isotope, and that's going to equal the average atomic weight, which is 63.546 AMU. So we're just going to go solve for this. So we might subtract this from both sides. I'm going to divide both sides by the fraction that's the second isotope, and then we should arrive at the answer V for that one when we do the arithmetic. Okay, that's all for this practice quiz. Thanks for the attention.